Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in today's video, we'll focus on solving exponential equations by rewriting them using the same base. And to do that, we need to first review our exponent laws. So let's get into it. So here on the screen, we have our 6 exponent laws. The first, second, and third law are our product law, quotient law, and power law. The fourth law says that anything to the power of 0 is equal to 1. And the fifth law is what happens when we have a negative exponent. And then finally, the sixth one is what to do when we have a fractional exponent. So if you're not familiar with these laws, I would suggest to either copy them down or take a screenshot so that you have them handy when we go through some examples later. So what exactly is an exponential equation? An exponential equation is any equation where the variable is in the exponent. So here we have some examples. So for example, here we have 2 to the power of x is equal to 8. So notice how our exponent here is x. Or the second example where we have 25 to the power of 2x plus 1 is equal to 125. So again, notice that our exponent has our variable x. So all of these are examples of exponential equations. So the key idea here is that we're not solving for a variable that's sitting next to the base. So when I say base, I mean this number here. So 2 or the 25 or the 3. Those are called bases. So we're solving for a variable that is powering the base, meaning it is part of the exponent. And that makes these equations behave differently than your typical linear or quadratic equations. And exponential equations are often used to model things like population growth, radioactive decay, or compound interest. So understanding how to solve them is super important for real-life applications. Now, let's go ahead and take a look at some examples. So the first example, we're asked to solve 2 to the power of x is equal to 8. Well, obviously, we can just think about exponents and arrive at an answer that is 3, because we know 2 to the power of 3 is equal to 8. But what we should try to do is train our brain to rewrite the problem so that the bases are the same. This is a powerful method for tackling exponential equations. So meaning, on the left-hand side, our base is 2, so we will leave it as 2 to the power of x. But on the right-hand side, 8 can be rewritten as 2 to the power of 3. So we're going to write that as 2 to the power of 3. So now, because we have the same base on both sides, both are 2, we can now just compare the exponents. So what we end up with is we get x is equal to 3. Now let's take a look at another example. This one is not as obvious as the earlier one. So using this strategy, we're going to rewrite both the left side and the right side so that they're the same base. So if we look at the left-hand side, we start with 25. And we note that 25 can be rewritten with a base of 5. So we can write 25 as 5 to the power of 2. And then we still have our exponent here, which is 2x minus 1. Now the right-hand side is 125. And that can be rewritten as 5 to the power of 3. So now we have the same base, but there is one more step that we need to do on the left-hand side. So using the power rule from the list of laws above, we need to multiply the 2 to the 2x minus 1. So that means the left-hand side is now going to be 5 to the power of 4x minus 2. And then the right-hand side stays the same, so it'll be 5 to the power of 3. And now we can go ahead and just compare the exponents. So meaning we can set 4x minus 2 equal to 3. And now performing our basic algebra, we end up with x is equal to 5 over 4. Okay, now let's take a look at one more example. So for this one, we need to simplify the left-hand side a little bit first. So we need to use our product law to actually combine these two expressions. So the good thing is both of them already have the same base. They're both base 3. So using the product rule, that tells us that we can combine them by adding the exponents, meaning the left-hand side is going to be 3 to the power of x plus 1 plus 2x, which ends up being 3x plus 1. And now the right-hand side, we have our numerator, which is 243. So that can be rewritten as 3 to the power of 5. Now square root 27 can be rewritten as 3 to the power of 3. That would be 27. And then we need to divide it by 2 because we have the square root there. Now the next thing that we need to do is use the quotient law to rewrite the right-hand side. So that ends up being 3 to the power of, and it'll be 5 minus 3 over 2, which gives us 7 over 2. And then the left-hand side stays the same. And now we have the same base on both sides, which means we can go ahead and just compare the exponents. So we're going to set the exponents equal to each other, and that gives us 3x plus 1 is equal to 7 over 2. Okay, moving the 1 to the other side is going to give us 3x is equal to 5 over 2. And then solving for x will give us x is equal to 5 over 6. So now after working through these 3 examples, a natural question that you might have is, what if I can't rewrite both sides with the same base? Well, that's when you start using logarithms, which we will cover in another video. So that is going to allow us to handle exponents that don't match up nicely. But for now, if you can rewrite both sides with a common base, this method is clean, fast, and avoids using logarithm. So now, let's do a quick recap of what we have covered in this video. The first thing we talked about was what exactly is an exponential equation. And that is when the equation has the variable in the exponent. And we went over our exponent laws, which is used to simplify expressions so that we can rewrite both sides and get them to the same base. And once we do get both sides to the same base, then we set the exponents equal to each other, and then we solve for a variable. So now it is your turn to give this a try. Can you solve this equation here using all the exponent laws we have listed above? Make sure to leave your answer in the comments below and let us know if you'd like to see more content on exponential equations in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.